Hi, this is Mrs. Slater. Go ahead and turn to where it says yet another graph by hand practice problem in your note packet. It's right after the 11.6 notes. So I just wanted to do one with you, and then hopefully Mr. Pickler can do the rest with you in class. Okay, so here we go. The y-intercept is always going to be located in the back of a polynomial, very similar to what we did with the quadratics. So in an order pair, it'd be 0, 13, always taking the sign to the left. Okay, and then we're going to draw arrows to represent the end behavior. The only part you have to look at the polynomial is the leading coefficient, or leading term. And since it's an even degree, and it is a positive coefficient, those are going to help us with our end behaviors. So to the left, it's going to, so in even degree, that means we're going to go both in an up direction. Okay? All right, and then use the rational theorem, rational root theorem to find all the possible. Well, we know the factors of 13 are 1 and 13, so that's that. And then D is going to be plus or minus 1. And then if you divide them, you get plus or minus 1 and plus or minus 13. So they're all the possible roots that we could have. And if we don't have a calculator to use, our guess and check method is going to have to work. So if those are our possible rational roots, we're going to start with synthetic division. So 1 is where I'm going to begin, and 1, negative 4, negative 14, 4, and 13 are the coefficients. Drop the 1, negative 3, negative 17, and negative 13. So that does indeed work, which is a good thing, because now we already have one of 4 roots. And the next one I'm going to try is in my possible list is negative 1. So I'm going to go ahead and break down this one if possible. Otherwise, I'll just erase it and start over. We have 1, and then negative 1, and negative 4, and then 4, and negative 13, and 13. So yeah, it doesn't always work out this nicely, but in this case, we'll just take advantage of this moment. 1 and negative 1 are going to be your roots. And then what is left, you have x to the 4th, x to the 3rd, and this is x squared, x. So if you're left with a quadratic, see if it factors. And in this case, it does not factor. So we're going to go ahead and do the quadratic formula. So 4 plus or minus 16 minus 4 times a times c all over 2a. And then once you figure out what's inside as the discriminant, it would be all over 2, and it looks like our answer is going to be 68. That does reduce because there is a perfect square that goes into it, which is 4. So you get 2 radical 17 all over 2, and for a final answer of 2 plus or minus radical 17. All right, so we have just found the other 2 roots. I'm going to go ahead and put them on my list. And just because I'm graphing, I'm going to go ahead and find out what they are approximately. So let's just go ahead to our calculator and make sure we can figure this out. So what we have here is 2 plus radical 17. Okay, so that gives us 6.12 approximately. And then if we do the other one, I'm just going to go second enter, and then go over to the minus sign and just change that. If I ever get there. Okay, so that's minus, whoops. So that's 2 minus, and then push enter to get negative 2, negative 2.1. So I'm going to put a negative, and something just happened that was negative 2.1 is going to be there. So we got both of those from the calculator. Okay, so now that we know the roots, we're going to be able to graph this. And from number 1, it told us that the y-intercept was 13. So we're going to graph that. 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Expect this type of graph because there's going to be so many different shapes and sizes that you're going to want an open graph like this. So there's your y-intercept. Part 2 gave us the end behavior. So I'm going to go ahead and make a little sketch. Again, that's not exactly where it's going to be, but it just gives me an idea of where those end behaviors are going to go. And then the next one is number 3 and 4 kind of go together. It tells you all about the roots. And the roots were at negative 1 and 1. Those are the easy ones. And then the decimals are 6.12. So 6, so 2, 3, 4, 5, 6 right there is a good indication of that one. And then negative 2 0.1, so it's going to be about right there. So it's saying that our graph is going to go through all 4 of those spots, and we're going to have the end behaviors going up on both sides. Okay, now if you look at the last part, it says determine 2 additional points and label them on your graph. Okay, so what would be a good 2 points, maybe 3 or 4 points, just to make your graph look better, is you see right here where we have a little gap. Okay, I'm going to try to get a point between there, and it looks like -2 would be a good choice. Okay, sorry about that little dot. So P of -2 is what I want to find, and if I want to find the function value, I can do synthetic division. So -2, and then you have 1, -4, -14, 4, and 13. And we've got 1, -2, and -6, and 12, -2, and 4, and 8, -16, and then you get -3. So as we've talked about in previous sections, -3 is my function value, so the point on the graph is at -2, comma, -3. So I'm going to go ahead and make that on my graph, -2, comma, -3. And again, that's going to give me a better idea of what my graph looks like. Okay, and then we already have something at 0. Maybe like anything in this section would be good to find. And I'm going to go right smack dab in the middle because it does say 2 points. And I'm thinking maybe at like 4. That would be a good one to do. Or maybe even 3. I don't know. I'm going to try 3. And if I do synthetic division with 3, I get a very, very large number. And you can go ahead and push pause and see if you can get the same thing. But you get -128. Okay, so that's the function value after you do the synthetic division or just plug and chug the number in. So -128, as we know, goes way off the paper. Whoops, sorry about that. Okay, it goes way, way off the paper, and I'm going to have it down here somewhere and like label it -128. And you can even label it here like this too. 128. Sorry, Microsoft Word is not very clear. And this is at -2, -3. Okay, so let's go ahead and graph. We know it goes up on the left side. So we're going to hit all the points we found. And think curves, think curves. It's going to go down there and then come back up and up and away. So you've got this little, and then I didn't use that one. I have a different one to use. Okay, so there is a sketch. Probably would get rid of that mess that I just made there. Make it look nice. And being on the smart board would be a lot better than this one. But anyway, I do what I can, and then that would be a good sketch of what it looks like. So I'm going to go ahead and conclude there with that one, and then Mr. Pickler will help you with the next 2. So good luck, have fun, and toodaloo.